All right, thank you for joining the Phoenix LiDAR Systems March 2021 webinar. We have two presenters today. The first one is Terry Omens. He is from our sales team. And then after that, he's going to hand it off to Conrad Quinterno, the head of our post-processing team. Terry, you want to go ahead and get started?
Sure. Thank you, Lito. Morning, everyone. Welcome to the March 2021 Phoenix LiDAR webinar, as Lito said. We're going to go over some, the topic of today is going to be SpatialExplorer 6 and 6 Pro. This marks the official release of those softwares, and yeah, we're really excited to share with you guys. So for anyone who's brand new to this, and this is your first time tuning into a webinar, we here at Phoenix LiDAR specialize in multi-platform solutions. Anything basically that moves, we'll put LiDAR on it, and customizing a solution to your needs. Phoenix LiDAR, it was the pioneer in many facets of the mobile LiDAR industry, being the first with many things such as first on a VTOL, first cloud processing software, first real-time point cloud visualizer, and many, many more things like that. We're basically here to customize and cater solutions to your unique needs. All right, now today is going to be all about SpatialExplorer 6. Some of you might know that SpatialExplorer is kind of the brainchild of our CTO, Ben Adler. It has gone over many, many revisions and has come really a long, long way. And today we'll be diving into the features and giving you an overlook of the entire package. So we do have multiple software platforms as well. We'll also be touching very briefly on LiDAR and the capabilities of that and the functionality difference between automating your processing and doing it manually. All right, let's jump into the software. So we have the three different tiers at the moment. SpatialExplorer Basic is the package that is included with the purchase of all of our systems. And SpatialExplorer Basic gives you control and basic exports, basically taking your raw data and exporting that to an LAS, and then going into your third-party software, TerraSolid, for example, and processing it there. SpatialExplorer Pro gives you all of those features, of course, and then adds the customized classification, as well as giving you access to different export tools and other features for calibration. And then LiDAR has very similar features to SpatialExplorer Pro, except you're limited to the fact that you are uploading to a pipeline. And while this does make the workflow much, much easier in terms of almost no human time and effort having to be put into processing, you will have some limitations in terms of customizing and troubleshooting different types of point clouds. A huge benefit of LiDAR, however, is that we do have flexible licensing available. Where if you have, say, a job a month and then you don't have a job for 2 months, there would be no need to subscribe for those 2 months. So you can save a little bit of money on something like that. So this is basically just a chart breaking down the feature matrix of the software. So I'll give everyone a second if you would like to take a screenshot to save this for later. We will also be providing this. But basically what this is breaking down is the features. As I mentioned, SE Basic gives you, of course, sensor control and different parameters accessing in the field, ability to do a quick field QA, and then, of course, SE Pro adding in those post-processing features, and then LiDAR containing most of those post-processing features, but being a little bit limited on the manual side of classification and troubleshooting. Okay, now we're going to take a quick look at what the new workflow looks like with SpatialExplorer 6 Pro. Okay, so SpatialExplorer 6 is now a complete A to Z workflow, allowing you to not only control the sensors while capturing LiDAR and camera data, but then actually taking that data to do an in-field QA and then process everything and being able to export your deliverables. This chart right here is a high-level explanation of that workflow. Basically taking all our raw data, staying completely within one software from all the way from collecting to delivering our final deliverables to whether it's internally or to your end client. So the first step in that process, of course, is collecting the data in the field. Spatial Explorer goes much farther than just controlling the sensor. You can actually see your CPU temperatures, how many satellites you're connected to, free space on the internal storage of the system, and so much more. One of the major features, of course, is the real-time point cloud viewer, allowing you to see that data in real time as you're capturing. And all of these features you see on here are included with Spatial Explorer Basic. This is just the sensor control side of things. So the ability to go in and change parameters and see what kind of uncertainties your IMU has is absolutely huge when you're operating the system in real time. Okay, so for anyone who's familiar with our LiDAR software, Nuvlab will be a familiar face here. And for those of you who don't know, Nuvlab is our trajectory processing software that automates the trajectory processing workflow. And we have now integrated Nuvlab directly into Spatial Explorer Pro. So Nuvlab customers can access their pipelines without ever leaving Spatial Explorer, allowing for a much, much smoother workflow and really keeping your entire workflow in one software. So a huge feature of Spatial Explorer 6 Pro is also the bore sighting and calibration side of things. LiDAR bore sights specifically allow us to quickly compute bore sight angles of different onboard sensors, and it completely automates that process, which can save you, of course, time and money collecting and getting those accurate data possible. Another key feature of SE Pro 6 is our unique calibration process. So LiDAR sensor manufacturers calibrate their systems from the factory, right? While they do that, we often find areas where we can improve that calibration and always make sure we're getting the optimal performance out of our sensor. And this really streamlines that process and allows us to be as accurate as possible. And let's talk about LiDAR Snap really quickly. LiDAR Snap is an algorithm we use to further smooth out your trajectory by using overlapping passes to effectively snap into the best possible estimated trajectory. Because of course, while the first step of our process is to post-process that trajectory, LiDAR Snap gives you even more accurate data. So this is a little image on the right here depicting how when we go from a unsnapped trajectory to a snap trajectory, how much it cleans up that data set. And of course, on the topic of calibration, this doesn't just go for LiDAR. We also use software within SE Pro 6 called CameraSnap that allows you to calibrate the cameras, which makes for nearly seamless RGB overlay onto point clouds, and we all love that. So something I see a very high demand for in this field is the ability to quickly QA your data set you just collected. And with Spatial Explorer, you can now do that and have access to multiple measurement QA tools right in the field, or to be used as the first step in the post-processing quality check of your data. And we all know that visual QA is just the very beginning when it comes to processing. So having a report on your data set for accuracy, optimization, and other parameters is absolutely crucial, regardless of whether the data is for in-house purposes or being delivered to an end client. And when it comes time to extract deliverables after processing that software, SE Pro 6 is more than capable with a slew of output options, including classification, raster products, vector products, giving you the best possible deliverables for you and your clients at the end of the day. So once you have your data set finalized and your products have been created, the last step in that process is to export them to a final format and that the end user has requested or that you require internally. And that applies not only to the point cloud, but also to those raster and vector products that we mentioned before. Okay, now I'm going to pass it off to Conrad Canterno, our post-processing, head of post-processing. And he's going to dive into some more specifics on the features of SE6 Pro. Conrad?
All right, thanks, Terry. Hi, everyone. Yeah, let's take a look at some of these new features that are specific to Spatial Explorer version 6. The first update that we want to share is the integration of our trajectory post-processing solution Nuvlab into our desktop interface. Nuvlab users will now have the ability to manage trajectory post-processing without leaving SpatialExplorer. The Nuvlab pipeline will essentially pull raw navigation data, IMU information, GNSS details, and reference station data directly from the SE project tree. So these main components of trajectory processing become layers of your project. A really nice benefit to this from a technical standpoint is that you can manage body to IMU rotations and lever arms with a single software convention. So that means you don't really have to worry about differing rotation orders or differing axes definitions, especially between softwares. Another helpful feature is that this Nuvlab integration will also automatically analyze your reference station files and return computed positions from Opus or Trimble RTX. Of course, users are also allowed to specify custom station details, so you really have all of the trajectory processing puzzle pieces in one spot and can get your post-process solution without too much effort. The next update is a major change that we made to how installation parameters are defined. Now we base everything on the IMU frame. This is not really a highly visible change, but it does have an important positive impact on user friendliness of our systems. If you watched the Vehicle Flexible webinar from last month, then it's pretty clear how much we value the simplification of solutions. Essentially, what this version 6 update does is make a single set of IMU to sensor transformation values that will apply to any unique orientation a system may have on its vehicle. It actually does improve the accuracy of system calibrations overall, but the most beneficial change is to really minimize the parameters that users need to reconfigure when swapping their system between vehicles. Terry already discussed the main 3 components of a LiDAR dataset calibration with LiDAR-Snap. Those were number 1, bore sighting, number 2, sensor intrinsic corrections, and number 3, trajectory optimization. SpatialExplorer 6 is running our 4th version of LiDAR-Snap. This version was built specifically to revamp that sensor intrinsic calibrations step. We've added some very important parameters to the model and reworked others that are reworked the way that others are computed. Probably most notably, we've added a nonlinear encoder calibration to greatly improve the performance of some scanners, particularly those in our Scout series. This new version of LiDAR-Snap really pushes the limits of modeling the geometric error within a scanner. Another improvement to LiDAR-Snap 4 is the addition of new trajectory optimization functions. We've added a spline-based model that allows for frequent corrections within each flight line. So instead of just adjusting flight line 1 by a certain magnitude and flight line 2 by another different magnitude, this method really fine-tunes each epoch along each flight line by making adjustments per small increment of time. This is really the best way to get tight relative accuracy. All of the functionality of LiDAR-Snap 4 is executed during a single processing step. So you can go from completely uncalibrated scanner data to finalized project data with just one tool. It is also possible to include ground control points into the optimization routine, but that's optional because we've also developed a new totally separate GCP methodology for SE6. Yeah, so this next update is regarding the options that we give users on how to handle control points. Surveyed control point files can still be read into SE and displayed with your LiDAR data in the map view as they always have been. But now in this version, the surveyed point type can be designated. It can be designated either within the file itself, like one of the columns of data can specify the type, or edited by the user once in SE. So like if you want to interactively choose how to designate a specific point. We have differentiated control from checkpoints as a very necessary step in making valid assessments of dataset accuracy. So those control points can be used to adjust the vertical and or horizontal, if the user chooses, absolute positioning of their cloud. Basically, first SE will run an automatic comparison between control, or those points designated as control, and your point cloud data, then report that offset to the user. The user can then decide how to proceed if they want to minimize the difference by adjusting their cloud in any direction. Checkpoints, on the other hand, are withheld from any process of adjusting the LiDAR data. These are our independent verification points that are used for making statements about accuracy. Producing accurate data is the overall goal, but being able to confidently state that data's accuracy is likely more of a significant process. And this is what we're trying to help users really accomplish with this update. Proper georeference is possibly the most important thing when stepping back and thinking about accuracy. There are just so many opportunities in most workflows to introduce some type of error, ranging from really small to ridiculously enormous when handling coordinate reference systems. And this is especially true when you're moving between many software. So we realized this and have worked to make the coordinate reference system tool in SE much more robust for version 6. Defining the datum and projection information for project data is important during both import and export, just to make sure that there's no mix-up or ever like loss of knowledge of what your data's projection is. So SE now handles both, just to help you ensure that your files are exported and referenced to the system that you really intend. Orthometric heights are also now a lot easier to achieve with the searchable list of geoid grids that users can download and utilize to reach their desired vertical datum. To really complete a project, we need to have a thorough account of data processes and final quality. There are a couple different types of users who might be interested. First, those who are responsible for monitoring each step while producing data, and also those end users who only really care about the final product. So we have created a flexible tool that can generate 2 different types of custom reports to satisfy both. First of all, we can produce a processing report. This includes a volume of detailed information that data processing teams can use during quality control stage to make sure that their data meets their acceptance criteria. A processing report could include metrics about flight line optimization, adjusted sensor calibration values, information about trajectory quality, accuracy assessments, and other various point cloud QC metrics like distribution of intensity values, for example. So these are all things that are really relevant to data producers. We also give the ability to produce a project report. This report has information about data acquisition. It describes some of the processing steps that the data has gone through, and most importantly, states the final data accuracy. Typically, this is what an end user would be interested in. It skips most of those quality control details that don't really matter after the data set has been finalized. The project report is what might accompany a data set as it moves between parties, you know, and makes its way to being utilized by that end user. And finally, in SE6, we are introducing a SLAM add-on. It's currently in the beta stage, so a free trial is given with SE6 Pro at the moment. The SLAM add-on does require data from multi-laser scanners, so it will work with our Scout series. We've tested SLAM and are still actively refining it using a variety of mobile and pedestrian acquired data sets. So if you're in need of LiDAR data from GNSS challenged environments, then a SLAM solution could be what you're looking for. And undoubtedly, we will have future webinars and publications specifically dedicated to this topic, but for now, the functionality is there and available for you to try.
All right, that concludes the webinar from Conrad and myself. If anyone is interested in looking further into SE6 and 6 Pro, please refer to our website for several videos that we created on functionality and workflow. If you're interested in purchasing or upgrading to SE6 or 6 Pro, please feel free to reach out to your Phoenix sales rep or shoot us an email at info@phoenixlidar.com. We'll make sure you get taken care of. From the release date today until April 30th, we will have an incentive program for both new and existing customers buying or upgrading to SE Pro, and that's a limited time price, and we're never going to go back down to that. So make sure you guys take advantage of that. Besides that, we're going to open up to questions. Lito, I'll pass it back to you, and we'll start getting some Q&As answered.
All right, we do have a few questions here. The first one, and I think Conrad, you can, or Ben, you can address this. Will this take away the need for Inertial Explorer? And I think that's probably a question that a lot of people have.
So SE Pro integrates with LiDAR mill to compute trajectories. So yes, if you have a valid LiDAR mill subscription, then you no longer need Inertial Explorer to do trajectory post-processing.
What about the Nuvlab portion that's in SE Pro? Ben?
That is the LiDAR mill Nuvlab. So
okay.
the button, if you go back to that slide, that is the LiDAR mill logo, and the idea is that you can use your LiDAR mill account to compute trajectories. So all the data, reference stations, rover, so raw GNSS and IMU data will be uploaded, trajectory will be computed, and then downloaded and reintegrated into your project. And this LiDAR mill integration is really just the first step. Of course, we're looking to make things as convenient and smooth as possible when it comes to crossing the online and offline border. So that's an ongoing project. But the trajectory post-processing part was the most obvious first step to take.
Yeah, and just to add a little bit to that, Ben, what we do have a subscription model specifically just for the Nuvlab portion of LiDAR mill, and that allows you to just subscribe to Nuvlab just for the trajectory processing side of things.
All right, the next question I have here is the point cloud in grid or scaled to ground using a combined scale factor?
So part of the coordinate system support in Spatial Explorer is also exporting to custom coordinate systems. So we have had customers, and it keeps happening that people come up with their own definitions or custom ground-to-grid scale factors or even local coordinate systems. The latter, which will be part of a future release, so that's in development right now. The local coordinate systems and determining transformations to match those. But yes, ground-to-grid scale factors are supported.
All right, here's another question we have from the chat section. Can you now apply the geoids to the trajectory and export from SE?
I think there is a way to apply a geoid to a trajectory. That isn't usually what we want to do, because the longer range scanners you have, we really want to apply the geoid to the points, right? Because the geoid undulation at where the vehicle was may be different than the geoid undulation of where the point is that you shot. So applying the undulation to the trajectory isn't technically the most accurate solution, but yeah, people keep asking for it, and you can apply a geoid during export of a trajectory into another format like SPAD or POF.
Okay, next question I have is, does this remove the need for TerraSolid?
That depends. So what we're focusing on is aerial acquisition at the moment, and there's just a different set of features between Spatial Explorer Pro and TerraSolid. And TerraSolid has different bundles, right? They have Terra Modeler and Terra Match and Terra Photo, and so on. So there is some overlap, and there are some customers who will want to stick with TerraSolid, and there are some customers who can elect to use Spatial Explorer Pro instead. It really depends on your needs, and it's a discussion that, if you're interested or if you're wondering, hit us up and we'll ask you for what your needs are, and then we can give you a better answer.
All right, next question I have here is, would this require the rover to be upgraded to version 6 as well?
We very much invest work in keeping Spatial Explorer backwards compatible, which can be difficult at times as calibration models change or conventions change. So technically, yes, Spatial Explorer Pro can process older systems data sets, but it is clearly less accurate, less convenient, less streamlined, and at some point, depending on what version of rover you're asking about, also less supported. So we still do offer updates of rover, even to the first system we ever sold. But at some point, yeah, it's a good idea to update, because things have changed a lot in those years.
Okay, next question I have is, can you tell us a little more about how project data quality is assessed in SE Pro?
Conrad, you want to jump in here?
Sure, yeah. I think the two main ways that we view the quality of the end product, the point cloud product, is the relative and absolute accuracy. And so SE Pro will run reports and give you a statistical analysis of both of those. The relative accuracy is a measure of how well overlapping passes match each other. So it's really giving you a comparison of the offsets between each flight line and any that overlap it. And then the absolute accuracy is a measurement of how well your point cloud data is matching the surveyed ground points that you've specified as independent checkpoints. There are other quality control aspects to the report, but those are kind of the main two that I think in the end most people are going to be looking at when they're trying to decide if they're going to accept a a data set as final or keep working on it?
There also is a lot of manual things you can do. So in SpatialExplorer, we've invested quite a bit in being able to cut profiles, to colorize by flight line or by time, to colorize by return index, to see that maybe it's the second returns that give you the ground model that you wanted, or not, or why, or looking at scan angles. So we use SpatialExplorer internally to evaluate new sensors, for example. So it's quite geared towards very detailed data analysis.
Okay, next question we have is, will the software work with data from other scanners like the Leica MS60 total station?
So what SpatialExplorer Pro can do is import LAS files. What we're working on and what it cannot yet do is registering multiple external scans, like from a static scanner to an aerial point cloud. That's a request that keeps coming up, and yeah, I hope we'll have some good news in one of the next webinars.
Okay. Can alternative base maps be provided via URL instead of OSM? Maybe, for example, maybe he has a past survey on a map server that the customer wants to use.
No, I would like to hear about how and why you'd like to do that. If you send an email to support@phoenixlighter.com, then yeah, please tell me what exactly you'd like to do, and I think we can probably make that work.
Okay, there's a couple more that I have. Are there any new point cloud classification algorithms being offered?
So we have improved the ground classification, and we have very much right now are also improving the speed of those algorithms. On LiDAR-Mill, you will find a free trial for AI classification for all of our subscribers. We also presented that in one of the more recent webinars. AI classification is not yet available in SpatialExplorer, so in the offline version. That's on the horizon, but that's not in 6.0. If you're missing a filter, we'd also like to hear about what that is. So if you could let us know either in the chat or in an email to support, thank you very much.
Okay, there's a couple more. This one I'm not sure we can answer, but we'll give it a shot. What is the final average cloud thickness expected after running LiDAR snap with a Scout 16 or Scout 32?
It depends. So we have seen, well, it depends on the scan range, it depends on the surface type, it depends on the reflectivity, it depends on the incident angle. So it's hard to really specify one number. But we have seen a cloud thickness that is below the pure ranging spec of the LiDAR. So the HDL 32, for example, is 2 centimeters, and we have seen thicknesses, I think, at 2.8 centimeters or 3 centimeters, somewhere around there. If if all those parameters come together, it's very hard to specify. There's not one number. So if you're scanning something from far away and it's dark, like the surface isn't very reflective at 905, then it'll be more. But essentially, we're calibrating down to what the sensor can do in terms of ranging performance now.
Okay, here's another question that we still have a few more that are coming in. So is SpatialExplorer 6 Pro meant to replace LiDAR-Mill with this update?
They're really two different animals. No, it's not meant to replace LiDAR-Mill. LiDAR-Mill and SE Pro share a lot of code in the core, but there's just some things that one cannot do that the other is very much capable of. Like data sharing is something that LiDAR-Mill obviously is very, very good at, and automated processing, and even giving your customers access to project reports and whatnot. So our customers can create accounts for their customers to share data with, or just simple hosting of point clouds and these kind of things. On the other hand, where Spatial Explorer excels is the manual inspection and processing part, where just the interactivity is a limit in LiDAR-MIL. So I think they're quite complementary, but yeah, each has their strength, and that'll probably remain so for a while to come.
Okay, another question I have here is, so do you have to have LiDAR-MIL in order to use Nuvlab and SE? And I think the answer is that you can purchase Nuvlab alone without having to have the full LiDAR-MIL package. So the Nuvlab portion of LiDAR-MIL essentially is a lower price than a full LiDAR-MIL, but that works in conjunction with SE Pro to take care of the trajectory post-processing features. Correct?
Yeah. Yes, I think Terry already mentioned that earlier. Yes,
okay.
Exactly right.
Okay, I do have another comment here that says they would love to see building and vegetation filters. Is that something that's possible?
Well, that's something that is on LiDAR-MIL right now, and yes, that'll find its way into Spatial Explorer soon. So on LiDAR-MIL, you can do the AI classification, and there's a lot. And you can go back in the webinars. There's a webinar that includes that and shows some sample data, and you can try it out on LiDAR-MIL too. But yes, for offline processing, yeah, point taken.
And I think we have one more question. Would you like to comment on the trajectory post-processing engine behind LiDAR-MIL?
It's based on the same inertial explorer that you're probably used to using.
Okay. All right, I think that covers it. Ben, is there anything else that you'd like to add that maybe wasn't covered in Terry or Conrad's presentations?
No, there wasn't. But yeah, essentially, we'd like you to try Spatial Explorer 6. We're very open to feedback. It's making quite some progress in recent months, and we're very happy about where it is. But on the other hand, there's always going to be requests like, well, what we just discussed, and the bringing in static point clouds and maybe even calibrating against them, and many requests that come in daily. And that's a great thing, and we have had some very early alpha and beta users who've also been very helpful. I want to thank those too, because that's incredibly helpful and also motivating to see how at first a point cloud with 500 million points is a problem, and then later we process 3, 4, 5 billion points, and it's really coming together quite nicely. And yeah, we'd like you to try and let us know how it works for you. And we're pretty confident that even manned projects are really no longer a challenge for SE. So yeah, thank you for your time.
All right, on behalf of the team at Phoenix LiDAR Systems, we thank you very much for joining this month's webinar. Again, if you have any questions about specific products, either contact your sales rep or go to info@phoenixlidar.com or contact info@phoenixlidar.com. And you can always go to phoenixlidar.com to find the latest information on our products, and also to check in if you want to see a replay of the webinar. Thank you very much, and we will see you all next month.